So I'm in the software field. I want to get a little feedback from the audience as we start off here. I want you to think about software that you use on a daily basis and come up with just one piece of software that you use regularly that you enjoy. It does what you think it's supposed to do. It does it in a way that you think is intuitive, and it just works. When you've got that in your mind, I want you to just put your hand up. All right. Now, keep them up. Keep your hand up if you use that software at work. All right? Keep your hand up if that software was written by your internal IT department. Exactly. So there's good software out there. But for some reason, our corporate IT departments can't seem to produce it on a consistent basis. Right? We look at companies like Google or Zynga or Groupon, and they're consistently producing good software. Well, except for Google Wave. But for the most part, they're producing good software. Right? And if we look at the open source community, they're consistently producing good software. In fact, there was a study in 2007 done by Harvard Business School, and they did a comparative analysis of open source software packages versus packages written in corporate America, right? And it was a one-for-one comparison. So if it was a customer resource management tool that was done open source, they compared it against customer resource management tools done in corporate America. And what they found consistently was that the open source software was 8 times better than the software written in corporate America. Better in terms of perceived usability, in terms of flexibility, in terms of scalability, et cetera. Now, the real quandary for me here is most of the folks that I know that are regularly contributing to open source software, software that is a resounding success, by day work in corporate America and are producing software that is consistent failure. So this leads me to think that maybe it's not the developers, maybe it's not the teams, maybe there's something else at play here that results in this. And to give you a scope of the failure, if you will, another study recently done showed that the amount of money lost on 100% failures in implementations and builds of software in America, in corporate America, average out to $1 million per project attempted. Right? Now, this is stuff that never made it to being used by anyone. This is just money that was lost on projects that didn't even go live. The projects that go live, on a global scale, the amount of money we would have to spend to get those up to snuff with open source, to bring them current, and to make them good usability, according to the Gartner Group, by 2015, it would cost $1 trillion to fix the software written by corporate IT departments. So I want to talk a little bit about where I think this is coming from. And these ideas aren't actually new, but I discovered them after doing some research. I kind of found this on my own and then started looking for, is this really true? Is this possible? So I want to talk a little bit. There's a book in our industry called The Mythical Man Month. It's written by Fred Brooks in 1975. If you ask most software developers that I know to name one of their top 10 books, name their top 10 books, that book is in there. It's highly influential in our industry, right? And in that book, he talks about Conway's Law. Conway's Law, paraphrased, is that the software produced is a direct reflection of the communication structures of the company in which it is produced. Now, This is actually an homage to Conway himself, who was talking about systems in general. Conway wrote a paper in 1968 for the Harvard Business Review where he was talking about any kind of systems. He was actually talking about manufacturing of automotive components. He talked about military weaponry, and he also talked about software. And his point was the same, that the systems that we produce are a direct reflection of the communication structures in our organization. And Brooks went on to say that what we find in software is the first solution is almost never correct. Therefore, the organization has to be flexible enough to change in order to derive the correct solution. So how did I kind of come across this? Well, what I do for a living at this point is I rescue projects. I go into organizations who are trying to get software out to the public, and for whatever reason, they can't get it done. And typically what happens when they bring me or my compatriots in, what they're looking for us to do is teach the software developers to be better at their job. That's what they're asking us to do, make them write good code. But what we find is while there are things that we can teach the developers, the real fix is at a completely different level. So I'll kind of walk you through a typical scenario. We'll go in and we'll meet with the company and we'll ask the folks in the IT department, how is it that you write your software? Say, oh, well, this is very simple. We have a business analyst, and they go and they gather requirements from the business folks. They then hand all of that documentation off to an architect who designs the overall system at a very high level, who then hands that over to the development teams who actually build it, who then hand that over to QA, who actually test it, who then hand that over to another group that eventually moves it out for the end user, right? And we map this process out, and we take a look at what's going on, and we look at where the bugs are in the software and where the issues are. Every single time what we find is that they're in the gaps. It's the handoffs and the divisions between these silos of function. When the analysts finish documenting the entire thing, they hand it off to architects who then read through it, and when they have a question, the analysts are already off doing something else. And the way that we fix this, one step at a time, we start to bring the team together. We'll suggest things like, hey, maybe you don't need to actually design the whole thing up front. Maybe you could just do a little piece. And let's just write that one little piece and get it out there and see what people think of it. And if they hate it, let's not do anything else. And if they love it, let's keep going. If they've got some feedback, let's make the changes that they're asking for. So we get into this cycle where we're doing this little tiny pieces of delivery, but we still have these problems. There's still these handoffs. So then we encourage them to all get in the same room. Hey, what if you actually all sat together? Well, that's impossible, right? Because the analyst reports to the business analyst group over here and has all of their objectives they have to meet, and the architect reports to this group and the developers. They're all separated. They all have different management. They all have different objectives that they are supposed to be meeting. And interestingly enough, none of them, save perhaps the developers, have the objective of delivering software, yet all of them are involved in the process. So eventually we can convince them to let these people sit together, work together, break down the silos, flatten the organization. And what ends up happening is that team now starts producing much better quality software. So there's another round, there's another level. What ends up happening now is I've got one team that's doing really well at creating the engineering systems. One team's doing really well at order entry, and one team's doing really well at warehouse management. And now we decide that we want to make a website that allows our resellers to go online, real-time configure a product, get a custom price for them, and determine if it's in our warehouse or if it's in their warehouse right now. And the same thing happens. What we discover as we start looking at this is the problems in the software are again in the gaps. We've got one team that's working on sales. We've got one team that's working on engineering. The sales guys, all they care about is the customer gets the product they want. All the engineering guys care about is the customer gets the product that we can build. And the two of them don't like each other, and they don't get along very well. And that is perfectly represented in the software. And the way that we fix it, again, is we bring the teams together, we bring the people together, we flatten out those silos, we get them to all cooperate. And they're able to solve those problems, and we're able to deliver good software. So what can business learn from this? Well, it turns out that Brooks and Conway early on were right. It's not just software, it's any system. We look at Southwest Airlines. Southwest was looking for ways to increase efficiency and reduce costs. And they have logical silos within that organization, right? You've got the grounds crew, you've got the ticketing agents, you've got the food services crew, et cetera. And as they looked at each of those silos, they were struggling to find any place else that they could increase efficiency without having a major impact on their end customers. So they put a committee of people together. They drew people from each of these various silos, and they put them into a conference room for 10 hours a week for 3 months. And they came up with 17 different recommendations for improving efficiency in the organization. And every single one of those improvements was in the gaps. Every single one of those was how they handed off information, how they worked together. Right? A couple of years ago, there was a study by the University of Maryland in cooperation with Microsoft Global. And what they were looking at were all of the projects and initiatives that Microsoft had been involved in terms of software development. And they gathered a ton of metrics around this. They were looking at the complexity of the code. They were looking at the way that the teams worked together. They were looking at the management reporting structures, how distributed were the teams, how close together were the teams. The general assumption was that they would be able to predict the success or failure of a software project based on the quality of the code that the team was producing. If the team is producing good quality code early, the project's probably going to be a success. If not, it's probably going to fail. Well, no matter what they did, no matter how many different combinations and permutations they came up with, the best they could get was less than 60% precision and recall on their predictions. So basically, it was a coin toss. Excellent software, still failed. Crappy software, still worked. So they started looking at the other metrics that they had been gathering. And what they discovered was there were certain pieces of information about the way that the team was actually organized, that when we combined those together, we got an 85% precision and recall on our ability to determine if a software project was going to fail or not. The quality of the actual hands-on keys activity meant less than the quality of the communication between the people trying to build the systems. And they came up with recommendations for everyone inside of Microsoft, saying, look, this is what we need to do to build good software from now on. One, we need as few people as possible to touch the code. So now what that means to me is the team needs to be small. Not tiny, small enough. There's some number in there that's the right number of people that are actually involved, and everybody else becomes, just extra, noise, pollution. Two, we need low team turnover. Now, this seems like a no-brainer, right? Of course, if people leave, there's a problem. But a lot of times in organizations, what happens is team turnover doesn't just come from someone quitting. Team turnover comes from we shift people around in the organization. Oh, she's got these really great skills, and this team needs it, and we move her. And the team loses that knowledge, but the team also has to learn how to behave and function with someone new, right? So don't change the team once you've got it set up. The next thing that they found was you need a high worker-to-manager ratio. More workers, less managers. The people who actually do the work need to make the decisions. The more levels of hierarchy you have, and the higher up in that hierarchy you have to go to get a decision made, the slower everything is, the worse those decisions are. And the final thing they recommend is the team has to do all of their own work. They're responsible for everything that they do. Now, if we think about organizations that I typically go into, There's the business analyst that's in one group. There's the architects that's in another group. There's the developers in another group. No, the whole team, everything that team needs has to be contained within it. There's no separate group that sets standards. There's no separate group that checks for quality. There's no separate group that gathers together the requirements or anything else. The team has to be able to work together as a consistent whole. So my takeaway from this, for me personally, and I'm hoping for at least some of you, when we look at what it took to fix software teams, it turned out what we were actually doing was we were fixing the company. We did very little to improve the way that the software was written, and we did an awful lot to improve the way that the organization was structured. If we go back and we look at open source software and why is it that open source software is so phenomenally successful, as a general statement, right? They meet all these criteria. Few people touch the code, right? The team, every responsibility they need is right there. There's no managers on an open source project. This is how we need to run our organizations. This is the change that corporate America needs to make. The software is merely a hyper-reflection of your company. If your company is unable to deliver good software, it's because something in the organization is dysfunctional that needs to be taken care of. Thank you.